right, so we're just computing this, 4.85 times the square root of 1 over 55 plus 1 over 91, and we get 0.83. So that is the standard error of the difference. So now we're going to use that as the denominator in the t-statistic. So remember what we're doing here. We're looking at what we're trying to do a t-test on looking at the difference between whites and East Asians to see if that is significant. So let's go up here, and we saw that the whites reported talking an average of 5.5 hours to their parents weekly, whereas the East Asians was only 2.5. So we're looking at, is that difference of 3 too big to be due just to random variation? Is that going to be significant? So the usual t-test is the observed difference of 5.5 minus 2.5, that difference, which is 3, minus 0, the expected, that difference, which is 3, over the standard error for difference. So here we have 3 over 0.83, and we get 3.61 as our t-stat. Now remember, there's a different t-curve depending on the numbers of degrees of freedom. So what are the degrees of freedom here? Well, the degrees of freedom right here, of course, remember, the degrees of freedom are associated with this standard deviation of the errors here, this right here, and that is figured on the basis of 179 observations. So degrees of freedom here. So this is the degrees of freedom for the t-test. All right, 179. So that's n minus the number of parameters, which is the number of groups. And so it was 183 minus our 4 groups. That's how we figured that out. Okay, so now what's it saying? So now I'm giving you the p-value here. It's very significant. You're probably not surprised, of 0.02%. But remember, we picked out this difference. Whoops, sorry. We picked out this difference. After looking over all of them, I said, wow, that looks like a really big difference right here between 5 points. So I cherry-picked that. I didn't state ahead of time I think the difference is going to be most significant between white and East Asians. So, so I have to adjust this p-value by the number of possible pairwise comparisons there are here. So there's 4 groups here. So how many different possible comparisons are there? Let's write this down. The p-value is 0.02. The Bonferroni correction would multiply that p-value by the number of pairwise comparisons. And that is going to be 4 times 3 divided by 2. So that's 6. In general, it's g times g minus 1 over 2, where g is the number of groups. All right. Now we're going to do the same test by the re-randomization. Look back at part A. I tested the same null using the re-randomization test. This histogram to the right shows the distribution of R's resulting from 60,000 randomizations. The vertical line falls between 0.2 and 0.3. Give its exact location to 4 decimal places. Show work and circle your answer. So they want the exact location of this right here. Well, what does this vertical line represent? This vertical line represents our observed sample R. We're comparing, so we did all these randomizations. We're under the null, we just randomly distributed the 183 responses, randomly assigned them to the four ethnic groups and computed R for each of those 60,000 and drew a histogram of it. And we're wondering how likely it is that our actual data, our actual observed R, came from a random distribution, which is what the null would state. So this is our observed. So how are we going to get that? Well, we already have that. We've already figured out the observed R squared right here. Yeah, right there. That's our observed R squared. So we know that's our R squared. So our observed sample R is just going to be the square root of that. The square root of 0.0719. And when we do that, it better fall right there, and it does. It's 0.2681. So that's what that is right there. That's our answer. Okay? Because that was R squared. Okay, now true or false, the area to the right of the vertical line represents what? The percentage of randomized R's is big or bigger than the R we obtained from our survey sample. That's true. These are all randomized R's, and this is the percent that are bigger, the area to the right of that. That's true. The p-value given by the randomization test. That's exactly true. It's the p-value given by the randomization test. The percentage beyond our observed sample R. The p-value given by the f-test. No, that's false. The f-test is not basing it on some empirical sampling distribution. It's basing it on an idealized sampling distribution based on the assumptions we talked about before. So this is false. Okay, and if we actually got an actual p-value here, it wouldn't be the same as this one. All right. You can't tell what this one was. Let's just look. This one said what? Less than 1%. That's what we got by the F. And this probably might look like less than 1% too, but they're not exactly the same thing. All right, so now we're going to move on to the next page. Okay, so we're on question 9 now. It says 9 numbers are divided into 3 groups as shown below. And so now we're going to compute the sum of squares between the groups, between these group means, the sum of squares within each group. So the sum of squares between the groups is what? So we're just going to look at the group. It's the sum from I equals 1 to n, and there's 9 now, of what? Of the predicted, so that's y predicted minus the overall mean squared. Okay, so let's do that. So for the first one, we're predicting here. So the overall mean squared, so that's going to be 5 squared, right? Plus something minus 5 squared plus something minus 5 squared. Okay, so now for the 3 observations in this group, all of them have the same predicted. What is it? We're predicting the group mean. They're all in group 1, so for each one of those observations we have a 2. For each one of these observations we have a 6. For each one of these we have a 7. And there's 3 observations here, 3 there, and 3 there. If there were 4 in each group, we'd have to multiply by 4 here. All right, so now you might want to just check that inside the parentheses here, if we didn't square, it would add up to 0. That's why we have to square them. These differences, here's a -3, here's a 1, and here's a 2, so they do add up to 0. So we're just going to say, okay, so this is right here, we're going to say this is 3 times -3 squared, so that's 27, plus 3 times 1 squared, plus 3 times 2 squared, so that's 12. So we add them up, and that's 42. Now you could just subtract 42 from 66 to get 24 here, but instead we might as well just do it from scratch just to check our work, and in case you wanted to do this one, if this is the one you remembered, and we're then going to just subtract that from this to get this one. Okay, so now this is just your observed, all your 9 observations, minus your expected, right? Okay, so for the first 3 observations here, we expect 2, right? And so we observe 0 minus 2, so that's 0 minus 2 squared. And this one is right at its expected, so that's 0 right there. And this one is 2 above its expected, right? And now we'll go to the next one. Here, the observed minus it was just a variation here around this mean, group mean. It's the observed, here's your observed minus the predicted. So it's, again, this one's 2 below expected, this one's 2 above expected, and this one's right at expected. And same with this one. So let's write that down. So we have negative 2 squared plus 0 squared plus 2 squared. And now let's look at our last one. Again, these are symmetrical around the mean here. And this one's 2 below, this one's right at, and this one's 2 above. So we have negative 2 squared plus 0 squared plus 2 squared. Okay, so now we add them all up. And what do we get? 4 plus 4 plus 4 plus 4 plus 4 plus 4. So that's 6 4s is 24. And you can check that what? 27 plus, check that, what? Not 27, these two right here. That 24 plus 42, right? That sum of squares within plus sum of squares between equals sum of squares total. And it does. We're good. All right, so now the next one. If chi-squared doesn't yield significant results, is it possible the f still would? Okay, now significant results are determined by p-values. So how do you compare the p-values? What do we know about the p-values between comparing chi-squared to f? Which has a fatter tail? F. F has a fatter tail. You can remember that. Fat. F has fatter tail. And remember, the p-value is the probability you get such an extreme value or even more. That's called the tail. If that tail is fatter than the chi-square, then this is going to be fatter. It's going to have a bigger p-value. Same with t. T has a fatter tail. You can remember that because f and t, I'll write it that way. That's good to remember. F and t, it's like fat, have fatter tails. Okay, so they have bigger p-values. F has a bigger p-value. That's the area in the tail. So it's going to be less significant. So less significant, right? And that's this answer right here. So it can never be more significant. All right, so what I strongly recommend that you do is to do this practice to make sure you understand all the problems in this practice exam, to look for, if you don't, then concentrate in the notebook on the examples, the relevant examples corresponding to the problems that you're not understanding as well. And for sure, do the ln kappa exam, where it has multiple variations, randomizations, particularly on if like you're having trouble with things like this. You can do this over and over again with different numbers. the conceptual problems are a little bit different, but there's a lot of them that you can just do over and over again with different numbers. So you can master everything here and everything that's on the long Kappa practice exam. People are asking me over and over again, does that mean if I can do this practice exam and the long Kappa exam that I'll be fine for the regular exam? Well, you'll do pretty well, but you're going to, I try to put some new problems on here. I won't throw anything at you that's not either in the homework or the notes for sure. So what I strongly recommend you do is also look at the practice homework and make sure you know how to do all those problems on the practice homework, for example. So that's my advice, and there's going to be office hours on tomorrow, on Friday, from 4 to 6, and on Monday from 2 to 4. I'll send you a message about that in email. Okay, so that's it for the practice exam, and good luck studying.